Hello, Algebra class. We are going to talk about lesson 4 in our study of functions and slope intercept. And you should have a vocabulary sheet that looks a lot like this, except yours is blank. So you need to start giving some of these examples, and we're going to talk through this. So the definition, which is what I want you to start with first. So the definition of a transformation is on graphs, it's where the line moves on a plane to create a new linear function. So it transforms it. So I want you to think, I don't know if you've ever seen the movie Transformers or if you know what transformers are. When you transform something, you make it into something different. And we're going to practice this quite a bit. And there are definitely characteristics of what transformation is. The first one is a vertical translation, which this one goes with your characteristic. So in your visual representation of it, you should have a normal graph, and you can start with a line anywhere. And then the line should run parallel. So you should have two lines and they both run parallel to each other. And in a translation, you start with one line. So let's say, for instance, you start with this line here. And then you'll take the ruler and you'll slide it in a left direction, which creates this line right here. And the figure slides vertically or horizontally to a new position. So you can slide it up and down, or you can slide it left to right. Either way, it depends on the line that you're using. And the lines run parallel, and that's really the distinguishing factor with a translation. Now let's talk about the reflection, what the characteristic of a reflection is. And I want you to notice that just like you would think of a mirror when you see reflection, you think of a mirror image of itself. So in this case, whatever your line is, and in this case, it's a function that is not linear, but you flip it across the axis and it reflects the exact thing that it was doing before. So if you started with this, you would flip it upside down to create this new function. So that's a reflection of the line. It's a new transformation of whatever your original equation is. And a lot of times they ask these things because maybe you want to see it like in a different location. You want to know in a vertical translation, a lot of times, like in this case, it looks like for every 1 hour you work, you get $5 an hour. Well, maybe they want to know, well, what would happen if you got $15 an hour? Well, how would that look on a graph? How much different would it be on the graph? So that would be a good example of why you would do a vertical translation. And in the reflection, of course, it could be you started with like your cost of goods sold, and you want to know where your break-even point is. So your break-even point might be here. Well, in the reflection, what you might want to do is, what if you changed your cost of goods sold? What would your graph look like if your break-even point was there? Those are examples of how you would use it in the real world. And then finally, in the last one, a dilation. The equation is actually flipped. So you change the X and the Y to see what the new graph would look like. So you might start with this line, and then you change of course, this one, the y-intercept is at 0, 0, but your slope, I don't know if you notice, your slope in this one is 1 and up to over 2. So in this case, they changed to the slope is different. So instead of up 2 over 2, then they might flip that, or up, maybe your slope is 1/2, up 1 over 2. You would flip that to up 2 over 1, and you would get a different line. So you're flipping things in a dilation. So the figure is stretched or compressed depending on what your numbers are. Go ahead and fill in your vocabulary sheet. Make sure that you also use words and the characteristics that you also understand, so that you understand why you would use this in